Hello, thank you for joining me here once more. I have a function f of x equal to x over x plus 2 where x must not be equal to minus 2, and we have been given a function that if g of x is 1 out of 2 f of x plus f minus x, and then another function h of x giving us 1 out of 2 f of x minus f of negative x, then show that one of them, which is one of g of x and h of x, define an even function and the other an odd function. So all this question is telling us is that we should solve this function to generate g of x, solve this function to generate h of x. Then when you finish, test each of them to see which one of them is even or odd. So that is it. We have already been given the f of x function that we can replace here to solve. So this is a question that is under even and odd functions. There is a video under even and odd function. Locate the playlist mass 1, go over that video, locate even functions and odd functions. I've explained them into details for you to grab the concept before you tackle a question of this form. But before I start, let me take a few minutes to explain a function that is even and a function that is odd. So when I have two separate functions such as f of x and then g of x, if I am told that f of x is odd, it will be given to you in the question whether f of x is odd or f of x is even. So let's assume f of x is even. If f of x is an even function, then when you test with a negative x, the result should also be what? A positive result. And let's assume this one is rather odd. Then what this means is that if we want to check if for an even function, we have to test the whole result with a negative x. So f of negative x, we can say something like testing with negative x. We always use negative x to test. F of negative x will result into what? F of x. For even functions, f is even, so for even functions, f of negative x will give you f of x. This means that a negative function will produce what? A positive result. Then g of x is what? Odd. So for odd functions, when I test with a negative x, g of negative x will give me minus g of what? X. So for odd functions, g of negative x will be equal to minus g of what? X. In the same way, they can turn it. Sometimes they can say g of x is rather even, and then the function f of x is rather odd. No matter which function, whether it is g of x, h of x, p of x, no matter which function, all you need to do is to test it with a negative value, a negative x. So when I test this one, g of negative x will give me, since it is even, it will generate g of x. And then for this one, f of negative x will give me minus f of x. So it doesn't mean that every day f of x is an even function. It will be given to you in the question. So with this concept, I can now take the question I have for you today to find g of x. So let's first work with g of x. So we have g of x being equal to 1 out of 2 into bracket f of x plus f of negative x. Then we know f of x to be x over x plus 2. So wherever I see f of x, I'll substitute x over x plus 2. So g of x is going to give us 1 out of 2 into bracket x over x plus 2 plus, then he said we should negate the x. So this means wherever you see x, you negate it. So minus x all over minus x plus 2. So this is it. Now, the only thing I can teach you is that anytime we have a negative function, because the numerator is negative, it means the right hand side of this equation is a negative function. We need to change it to a positive function before we can work on it. And how do I change it to a positive function? I just need to multiply the whole function by a negative 1. So this times -1, this times -1, this times -1. Then I can continue the file, otherwise the result will be incorrect. So now we have g of x will be equal to 1 out of 2. Let me indicate that step for you to understand. X over x plus 2 plus negative x all over negative x plus 2 all times -1. This -1, there's no need for me to do that, but I'm using it to explain. So this -1 affects everything in the bracket. So the whole equation becomes g of x will be equal to 1 out of 2 x over x plus 2 plus -1 times this will give me positive x all over -1 times this will give me positive x. So it will give me x, and -1 times 2 will give me -2. So now this has become a positive function. Now since it is a positive function, I can now work on it. Now your next step is we need to break this down to the simplest form. So I'll take LCM here. We take LCM for addition and subtraction. If this side is subtraction, I'll take LCM. If this side is addition, I'll take LCM. So for hold on with the 1 over 2, let's take LCM here. So the LCM is the denominator times the next denominator. So we have x plus 2, then x minus 2. So now we ask ourselves, x plus 2 into x plus 2, it will cancel. This one will cancel this. We are left with x minus 2. So x minus 2 will multiply the numerator x. So we have x multiplying x minus 2 plus x minus 2 will now cancel this one. It will go into this 1. Then we are left with x plus 2 multiplying the x. So we have x here, x plus 2. So that is what we have. So the function becomes g of x will be equal to 1 out of 2 into bracket. This time this will give me x squared. This time this will give me minus 2x plus x times x will give me x squared, x times this plus 2x, all divided by x plus 2, x minus 2. Put everything into brackets. So this is what we are having. Then we know that there is negative 2x here, there is a positive 2x here. They will cancel it themselves. So this and this are out. So we are left with the x squared and then x squared. So we have our g of x giving us 1 out of 2 into bracket. X squared plus x squared are the same. So when we add, we have 2x squared all over x plus 2 x minus 2. So this is it. Let's expand the denominator. So we have x, g of x into this is still giving us 1 out of 2 into 2x squared all out of. Now x times x will give us x squared. X times this will give us minus 2x. Then 2 times x will give us plus 2x. Then 2 times this will give us minus 4. So that is it. So our g of x will now be equal to, now we know that this and this will cancel. This and this are the same, positive and negative, so they will go out. So we are left with 1 out of 2 into bracket 2x squared out of x squared minus 4. So this is it. Now we are not done. There's something we can do here again. Now we have 2 here, 2 here. So this will now take care of this. So now we have been able to eliminate the half. So we are having g of x equals x squared out of x squared minus 4. So there's nothing we can do here again. Don't try to use difference of 2 squares here. There's no need. So now we have x squared minus 4, and this is our final result for g of x. So now that we have g of x, we check, is this g of x a positive function or a negative function? It is a positive function. So now we can test it with negative x. to see if it is even or odd, like I did in the introduction. So testing g of x with a negative x, what will be the result? So wherever we see x, we substitute a negative x there. So we have g of negative x will give us negative x. It is supposed to be squared out of negative x, supposed to be squared minus 4. So now when you square this, the result is g of negative x giving us the same x squared all over the same x squared minus 4. Now this means that if you want to really, if you don't know why, if you square something which is a negative value, you will get a positive result. So assuming x here is, let's say, 3, you can pick a calculator, take minus 3 into bracket all square, it will give you a positive result, which is 9. So that is what it, but if you don't put it in bracket, you will not get a positive value. So now this is our result. Now let's check if this is even or odd. In our explanation, we learned that when we test for a negative function for an even function, when we test with a negative value, the result is supposed to give us the positive function, and it's supposed to give us the same what result, but this is supposed to be positive, the same function given to us, but it's supposed to be positive. So when we look at this, we are generating x squared minus x squared minus 4, which is the same as the function g of x. So this means the function is what? An even function. So g of x is equal to what? Minus g of x, because minus g of x generated a result that is the same as this. So now you write a statement by saying since g of negative x, which is this one, which is this, equal to g of x, the same function here, it implies that, it shows that, or it indicates that the function given to us, the one we worked for, g of x, is an even function. We need to work for h of x. So let's move on to h of x. This is h of x. The formula given to us was 1 over 2 f of x minus f of negative x. So we already know f of x to be what? X over x plus 2. So let's substitute h of x, the values of f of x. So we have h of x will be equal to 1 out of 2. F of x is x over x plus 2 minus, we negate the x. This formula says negate the f of x. So minus x all over minus x plus 2. And that is what we have. Now we look at this side, we can see it's a negative function. We need to change it to a positive function before we can continue the calculation. So h of x will be equal to 1 out. So this negative one will make this side positive. So this time this time this time this. So h of x will give us 1 out of 2 x over x plus 2 minus negative 1 times this will give us x, negative 1 times this will give us x, minus this time this will give us minus 2. So that is what we have. Then the next step is to take LCM on both sides. LCM is x plus 2 x minus 2. How do you know you take LCM? Because it's a subtraction, it's a fraction. We need to group it together as one. Remember that we take LCM for negatives, two fractions, or a fraction and a whole number that are adding or subtracting. For multiplication and division, you don't take LCM. That is basic maths. So let me box on. X plus 2 will take care of this. It will cancel. We are left with 1 times this is giving us x minus 2. So this will cancel this. We are left with x minus 2. X minus 2 will multiply the numerator. So we have x into bracket x minus 2. Then minus. This will now take care of this. We are left with x plus 2. Multiplying the numerator, which is x, multiplying the x plus 2. So the h of x will be equal to 1 out of 2 into bracket this result. We are taking this result. But let me just expand. X times x will give me what? X squared. X times this will give me minus 2x. Then minus x times this will give me minus x squared minus x times 2 will give me minus 2x. So the result all over, let's expand this one to x times x will give me x squared, x times this minus 2x, 2 times x plus 2x, 2 times minus 2 give us minus 4. So that is what we have. Then we have h of x giving us, we have 1 out of 2 into, now which ones will cancel? We know this is negative, this is positive, so this and this will go away, this and this will go away, so we are left with minus 2 giving us minus 4x out of x squared minus 4. So this is what we have. We can now cancel, these 2 can cancel this, we are left with 2 here, so we have h of x equals 2 minus 2x out of x squared minus 4. So this is the result we have. Now before I can test to see if it is even or odd, I need to check if the function is a positive function or a negative function. As you can see, it's a negative function. I need to change it to a positive function first, then I'll test it. We don't test negative functions, we need to change it to positive functions first. So now to make it positive, I'll multiply the whole function by what? Negative 1. So we have h of x equals, this time this will give us 2x, this time this will give us minus x squared, this time this will give us plus 4. So let me rearrange it. H of x is going to give us 2x out of 4 minus x squared. So this is h of x. Now that we have h of x, we can test to see if it is even or odd. Now we test with a negative x. So wherever I see x, I'll substitute negative x. So h of minus x giving me 2 minus x out of 4 minus into bracket minus x all squared. So we have h of minus x giving us minus 2x out of 4 minus x squared. Remember, this will make it x squared, but there's a negative here affecting the function. So now we are getting a negative function. So we can see that when we tested with a negative x, we got a negative function. That explains the reason why I said you should change it from negative to positive before you test. Otherwise, we would have gotten an even function, which is incorrect. So now we have been able to do the testing. We have proven that the function is what? Function is odd. So I will take you back here. When we tested for a function, when a function is odd, when you test with a negative x, it generates a negative function. So you realize that when you tested h of x with negative x, you got a negative function. This means the function is what? An odd function. So you say that since function, so this is it. You have been able to test that the function is odd. The first one is even, h of x is what? Odd. My name is Daniel. If this video has been helpful, don't hesitate to subscribe to my channel. I will see you in my next video.